Electromagnetic radiation concerns energy traveling in waves. What we'll calculate about waves are the wavelengths, the distance from the top of one wave to the top of the next wave, and the symbol for that is the Greek letter lambda, and also the frequency, how many times this wave will hit this point, that line, per second. And so how many waves go by per second is called the frequency, and the symbol is the Greek letter nu. If you have two waves, this one has a smaller wavelength than the bottom one. So this wave is going to hit that point more times per second than this wave. And so this top wave has more energy. And so we'll also calculate the energy of each wave. Two constants we'll use in these equations are c, the speed of light. 310 to the 8th meters per second is how fast all these forms of energy travel. And so if your wavelength is in any unit other than meters, you'll have to convert to meters. The other constant is h, which is called Planck's constant, for a man named Planck. And notice it has the unit joules in it. And so we'll be using that Planck's constant to find energy of a wave. So the speed of light equation is c equals the wavelength times the frequency. Those two are inversely proportional. If you have a very long wavelength, then your frequency, the number of times the wave hits that certain line per second, is going to be very low, and so they're inversely proportional. And then we have this equation with energy. Once we know the frequency, how many times that wave hits a certain point per second, the more times the wave hits a certain point, the more energy it's going to transmit to that point, and so the two are directly proportional. If you increase the frequency, you increase the energy. So if you're given wavelength and asked to find frequency, you would just rearrange the speed of light equation and plug in your numbers. The constant speed of light, 310 to the 8th meters per second, divided by the wavelength you're given, would give you the frequency, which would give you 4.8 times 10 to the 14th waves every second, and so the meters cancel, and so your unit is either s minus 1 or per second. It really stands for how many waves go by every second. If on that same example you already have the wavelength and now the frequency and you wanted to find energy, you would just use this equation. And so energy equals Planck's constant h, 10 to the negative 34th joules seconds is the unit. And then you would plug in your frequency in per seconds, waves that go by every second. And so seconds cancels and you're left in joules. And so the amount of energy contained in this wave of energy is 10 to the negative 19th joules. What it really is telling you is every little photon or packet of energy traveling in this wave has that much energy. 3.2 10 to the negative 19th joules is how much energy every packet in this wave has.